Okay, hello everyone. So let's talk abstract. We're going to abstract, and let's go and just start thinking about what this all means. Basically, it doesn't mean concrete. And let's go and take that in case you're not very clear about what abstract means, or what concrete means, either of those. Abstract means intangible, vague, nebulous, not really clear, or just simply it's a concept rather than an actual physical item. Concrete would be an actual physical item. So when we go into making an abstract class, then you might have the idea an abstract class is made by, just calling it an abstract class. You might have the idea that it's supposed to be some kind of thing which is not, which isn't, what would we say? Which isn't really supposed to be an actual thing, just the idea of a thing. And I can think of one great one surrounded here with water and coffee and tea, a drink. Yeah, because, water, coffee, tea, those are all drinks. They're drinks with very different properties, even though they have some things in common. Let's actually brainstorm a few of those things. One thing I think that a drink would have would be some kind of effect. Some kind of effect it takes on a person. So let's go ahead and say public, and I'm going to say public void um, effect. So it's affecting you. I'm using the verb form here. It's going to affect you in a verbal way. So an effect it might have. Let's see, what kind of effect would all drinks have? I don't know. I'm actually not sure what ways all drinks will be able to affect you. So what I'm going to do is I'm going to put a semicolon there, and I'm going to make this be public abstract void, and I'm going to call it a day. Yeah, I'm all done. That's a drink. Perfect, right? That's it. That's all a drink really has. That's what I would say unifies all drinks, some kind of effect. So let's go a little deeper into that. I'm gonna make a drink now. Water bottle, public class, and we're back to just regular classes, but let's say water extends drink. So I'm gonna save that in the same folder, so that drink and water are here. And if we said that drink is more abstract because it's just a concept, then actual water is an item. So I'm not going to make it an abstract class. I'm going to make it be an actual thing. So one of the first things I would probably say about an actual thing is that it should probably deal with its parent class. And I say this because the moment I try to compile it, I'm going to get an error. You see, one of the things about abstract classes and abstract methods, well, really, let's grab two things. First thing is that if I tried to make an abstract item, you're going to find that there's a lot of trouble with it. For instance, if I were to say drink D equals new drink versus drink W equals new water, you'll notice that this one here will actually have an error on it. I'm going to go ahead and show you that. I'll explain later why I commented that out. But notice it's going to have an error here, and then that one won't, right? Because, you see, when it comes to an abstract, it's not concrete, meaning it shouldn't be a thing. So kind of like how when we made a list, and we said equals new list, and we were like, oh, error. It's like that Zelda 2 guy, error. Because on this side we can't have list, we must have array list, and I can show you that that would work. Yeah, so this is good because you see things like lists or drinks, cannot be on the right side of the equal sign. We can't instantiate, we say, instantiate any kind of abstract concept. So instead what we have to do is we have to make items that can be that thing for us. I'm going to make a few things. I'm going to make a water. I'm going to make tea. And I'm going to make, what was the other one I said? Oh yeah, coffee. Let me go and give these a bit more descriptive of names. Now let's start making these classes. Alright, first thing. Let's handle this part first. Why does water have an error on it? Well, the thing is, as it says here, water does not override at effect. Well, there's a reason for that. You see, overriding is implementing. And implementing is changing something from being this undefined method effect where Java looks at it and says, I have no idea what that does, and changes into something where Java says, oh, I totally know what that does. Like this. If I make it not abstract, and then I do that, there we go. So if I do that, now Java says, oh, I totally know what effect does now. It says it refreshes you, provided that the object that's affecting is water. Because if I were to go here and say, hey, call effect, calling effect, which is in this file, versus calling the effect of water, that one's not going to work because it says I don't know what that means. Even if I were to make it a public static method, it would still say, well, it'd still have a bunch of errors on that. I'll be honest, I haven't tried to make static abstract methods because that's just silly. But water's effect is totally easy, and there it is. Let's go and get tea and coffee in there now. As you might expect, it's pretty much the same thing, just public class T extends drink because tea is a drink. If I try and compile it, it's going to tell me I need to override, that I need to implement effect, public void effect. Oh, also, don't change the return type here. Don't change anything about it. Just simply use the normal, use whatever it was in drink. Whatever the parent abstract class, contains as an abstract method should be general enough that all children of that class are able to use it just fine. There we go. It relaxes you. So water refreshes you, tea relaxes you. If I feel like we have enough time to do coffee, coffee will obviously wake you up. Alright. Tea dot effect. And boom. Look at that. I can even change the order on these. Pretty nice, huh? Alright, so let's go ahead and get really meticulous now. Because I'm sure you want to see some uses for abstract class. It's not just, oh, it's on the AP exam, so we're going to learn about it because Mr. S says it's time to learn AP, always. No, there is also some use to this. We're going to plan an agenda for consuming these 3 beverages. That's right, we're going to plan out a schedule in case you forget to do things like drink water. Seriously, very useful stuff here. So, let's go ahead and do that. I'm going to go ahead and do something really, really like mind-blowingly crazy right here. So you know how these 3 things, I mean I haven't made this one yet, but you should assume that these 3 things are all drinks? You notice how I can declare them in the same way that even if I initialize them differently, initialize them as child classes, I can declare as the same thing. That means I can do this crazy thing like this. Watch this, watch this. This is really cool. I can make an array list of drinks. This could be my drink agenda. Sorry, I've been doing a lot of Python recently, so I've been snake casing everything. Back to the camel case. Equals new array list of drink. And I can start adding to my agenda, and I can say, hey, you know what? I'm gonna drink some water tonight. Or even better, this is inefficient and silly. I'm gonna just type it directly into here, just like that bookshelf class we did, that bookshelf that we did. I'm just gonna type these things directly into here, and it's gonna work. So I'm gonna drink some water, and then some more water, and then I think I'm gonna do some tea. I think that's enough water. It's time for the tea, and then we're really just gonna get down to business, and we're gonna drink a coffee. And then, of course, always finish up with water, because you want to drink more water. Alright, the only error I'm going to have should be coffee. So let's go ahead and make coffee. And notice, because of the magic of abstract, I already know exactly what coffee should look like. Or at least I know what a major function of coffee should look like. I'm going to assume that it's going to be kind of similar to these other two, and just kind of follow that same kind of thing. Same kind of format. With a nice exclamation mark at the end, because I'm so extra, I think is how the kids say it. Ooh, and of course that's going to have an error because I intentionally forgot to say extends drink, so it's actually a drink. Alright, I wonder if I'll actually edit this video. Oh yeah, I didn't make it do anything. Let's do some stuff. So I want to do a couple things. One, I want to go ahead and I want to drink these drinks. So I'm gonna get their effects. So for every single drink called bev that is in my drink agenda, I'm gonna go ahead and I'm gonna drink it. So drink agenda dot get. Oops, that was silly because this is a for each loop, so I don't have any of that I equals 0, I through the size kind of thing. The equivalent of this where I'd say for and I equals 0, I is less than drink agenda dot size parentheses plus plus I. I really hope you guys can see this, just in case you're having a lot of trouble seeing it. Let's grab something better. Where's my Narkson font? I thought I had a better font on them. Oh, there we go. Let's make that a little smaller. Actually. Yeah, here's the part where I get to find out that my video's been terrible because no one could read anything. It's alright. Probably not. I'll like zoom in or something if it is, because I'm not redoing all this. Alright, so for each drink in that whole thing, I'm going to go ahead and get the effect of it. And you should notice that now, boom, yeah, I get refreshed, relaxed, wake up, refresh. That's how we do it. But here's the thing, here's something that kind of bothers me about this implementation. I've drunk from the water, right? So like I drink water right here. But like, why is the water still there then? I think it'd be a much better example if I could then remove it afterwards. So here's what I'm going to do. I'm going to go back to the normal for loop. See how I ingeniously coded it in advance? That's the kind of thing you can expect from a brilliant guy like myself. Alright, so if I get that thing, what I'm going to do is this. I'm going to dot remove it. But I also want to do that dot effect, right? Because I want to remove it because I want to do dot effect. Yeah, I put that in completely the wrong order. Because I want to do dot effect, but I also want to do dot remove, right? No, but it's like, how can I have both of these things happening? Well, it's actually pretty easy. Remember, .get is an accessor, right? But technically, so is remove. Remove gets whatever is right there and deletes it. So when I do this remove, I take it out, so it's basically like this is my new list, but it also puts that item right there. So I can actually do the dot effect, and I would get each of them. Now here's the thing. I do want to point this out. What's actually going to happen here is it's not going to work properly. But let's at least notice that it will get the first drink. Yeah, see how it refreshes you from water? So yeah, that part actually worked. Now, what doesn't work about it is when it removes it, again, it's basically like this is no longer there. I, which was 0, becomes 1, but 1 is no longer this index, it's now this one. Whenever we remove things, we have to be careful, because it's actually going to skip over others. If we really were in kind of a bad situation, we could have gone to the point where we actually break out of the indices. You know, like we get a bad index out of bounds error. So whenever we do remove something, it's also a pretty good idea to go ahead and subtract from I. So I can do I minus minus, or I minus equals 1, or I equals I minus 1. There's a lot of things we can do here. But any of these things should do exactly what we want it to do. And boom. That right there means that I pretty much never leave I equals 0. And while there are better ways of writing this particular problem, I kind of like this because you're going to be seeing this arrayless trap all the time, where on any kind of practice materials we use, it's going to go ahead, it's going to remove something from there, but then it's not going to do this part, and that means it's going to skip over the next object, and I think the best way for you to be prepared for that is just to see it happen. But if I go ahead and have this minus minus thing here, there we go. It pretty much makes it so that way. It just is like, it's basically like if you want to see a nice visual up here, watch this. So it's like it eats it, and it's just eating it. Nom 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 nom. How refreshing. Okay. Let me get rid of that. That is how that would work. Pretty mind-blowing, pretty useful. My computer is kind of crashing, so let's just not worry about that. Or at least Dr. Java is crashing. Hey, I think we've reached the end of this lecture, actually. There it is. That is what an abstract class is. That's what it does. This is how it can be used. And I'm sure you can think of even more ideas for it. There are some awesome videos out there that you can also check out about it. Thank you so much for watching. Keep up the good work. Email me with any questions. See ya.